Howdy. This example of a X-linked or sex-linked trait is with a disease called hemophilia. This is a blood clotting disorder where individuals can bleed um, to extremes if they have an even very small injury. So it's a very dangerous disease, and it's not very common. However, it does follow a pattern of inheritance called X-linked or sex-linked. And this is another outline. It's kind of the same thing as my last video, but I just want to go through it again. It's in a little bit of a different order, and it's specific to hemophilia. Please note, a hemophiliac is a person with hemophilia. So in this first part here, it talks about females being normal carriers or having the disease. Males are either going to have the disease or not. And we talked about that in the last video. So here is an example of a female that's normal. Again, they have two capital letters. The capital letters represent X chromosomes that have the normal gene, not for hemophilia. Here is a female carrier. So this X chromosome is normal. This X chromosome is for hemophilia. We say this female is a carrier, but they're normal. They don't have this particular blood disease. In this next female here, we see two little H's. And these little H's, I highlighted them in pink here. Those are unfortunately the bad copies that indicate the diseased chromosome. So because this female has two bad copies, she unfortunately has hemophilia or is a hemophiliac. In terms of males, we have a male here, XY, that has the capital H. Again, the capital H is the normal X chromosome. So this male is normal, does not have hemophilia. And then this last example here is a lowercase h, X with a lowercase h and a Y. So the individual is male, but that lowercase h means that that male has hemophilia or is a hemophiliac. So in my question here, and I want to let you all know the problem set for X linkage follows almost this exact format for answering the question. So if you follow along with this video, you should be able to answer the problem set pretty easily. So in my question number 1 here, it says, show the cross of a man who has hemophilia. So here is an XY, a male with hemophilia. So that little H, and then I highlighted it. And then a woman who is a carrier. So here's my female, XX, and that individual is a carrier. They have one capital H and one lowercase h. And again, that lowercase h indicates the gene for hemophilia. So let's set up our Punnett square here. Let's set up our cross. Here we have our X and Y across the top, and then our X and X on the left. Note that you must carry those superscripts. So here we have the X capital H, X lowercase h. We fill in the boxes in our Punnett square. We fill in across, and then across again. Hopefully you are all following along, and down. Feel free to pause the video anytime you need. Let's bring that Y chromosome down. And it might help to even do this on your own. Now, once we have our Punnett square complete, again, these are the offspring. This is what we're interested in. And note, this side, these are female. This side, these are male offspring. So make sure you're paying attention to that as you're looking at what the question is asking you for. So out of all of the offspring, what percent are male and normal? So for males, we're only looking at this side. And the normal chromosome, the normal X chromosome, is going to be a male with a capital H. So only this box, and I'm just going to highlight here. Only this box is going to be a normal male. And that would be 25% of the total offspring. The next question, B, says what percent of the offspring are male and hemophiliac? And here we see this is our other male, and it has a little h. So this is going to be our male hemophiliac, and that's 25%, again, 25% of the total offspring. In C, it asks about a female that is normal. Okay, so what percent of females will be normal? Well, this is our female side, and this is our normal female. Even though that female is a carrier, she is going to present as not having hemophilia. This is that individual, and sorry, my marker kind of bled through a little bit there. And last but not least, here we have our last offspring. This would be our female with hemophilia, and that's 25% as well. I hope this is helpful. And again, when you tackle the X-linked problem set, I highly suggest you refer back to this video. All right. And again, feel free to reach out with any questions.